Hello. Hello students. Welcome to PGCET 24 Laksha 2.0. Myself Dr. Hanif Page. I will be engaging the classes for PGCET MCA Maths. So we will be discussing tricks and the tips. Tricks and the tips. So we will be giving theory. In addition to that, tricks and tips, how directly you can use the tricks, because some tricks will work, if not then we'll go for tips. So today we are discussing the topic on indices. In algebra, last session we had a discussion on the factorization, where we have studied the tricks, how to find the square of a number, cube of a number, and how algebraic formulae are applied to find the square or cube of a big numbers without using calculator. So now today's session we'll start with topic called indices. Topic called indices. Okay, students. So we are yes. Okay. So our topic is on indices. Indices, sometimes also we use the word exponents. 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 So when to use this? When to use this? So whenever, if you are multiplying a number several times, then this concept comes into picture called index. The plural form is indices or the exponents. If, for example, if I add a number a plus a plus a plus a plus a, how many times I have added? 5 times. So I can write 5a. 2 plus 2 plus 2 plus 2, if I add, I am adding 2. How many times? 5 times. That is 2 plus 2 plus 2 plus 2 plus 2. 1, 2, 3, 4, 5. So this is 5 into 2, that is 10. So this we know, students. Now if I multiply a 5 times, if I multiply a 5 times, then this can be written as a to the power of 5. A to the power of 5 means here a is multiplied 5 times. For example, if I multiply 2 5 times, then I can write 2 raised to 5, that is 30. So now here the new concept that comes into picture, this is called exponent. We read this as a to the power of 5 or a to the power of 5, or here a exponent function, exponential function. So here, students, if I write a to the power of n, a to the power of n, this is an index. N is power here. This is called power, and this is called base. This is called base. To read this, we can use a to the power of n. A raised to n. A raised to n. That is also most of the time we use a to the power of n. A raised to n, a exponent of n here. This is power, or this is index, or this is called exponent. So this is called the base. So this is a concept called indices. Now we learn the laws. We learn the laws of indices. Laws of indices. If I use the letter A, let A greater than 0 and A not equal to 1. A not equal to 1. Then the first law is a to the power of m into a to the power of n. Product of two numbers, two factors. One is a to the power of m, one term a to the power of n. Second term, here the first term is having index m, second term is having index n. You can see that bases are same, bases are same. When the bases are same, add the indices. So this is the first law. If two terms with similar bases are to be multiplied by each other, then indices have to be added. Example, 2 to the power of 3 into 2 to the power of 5. So bases are same, add the indices, that is 2 to the power of 8. This is the first law. Second law is about, here it is a multiplication, then it is a division. If two terms are divided whose bases are same but indices are different, then you have to subtract the indices. When you multiply, you have to add the indices. When you divide the terms whose bases are same, then you have to subtract the indices. For example, 3 square by 3 cube. You can see that bases are same. 2 minus 3, that is 3 raised to minus 1. 3 raised to minus 1. So these are the two laws. The third law will be the power of power. Power of power or exponent of exponent. When we have a term whose base is a, its index or power is m, its power raised to power becomes extra power. Okay. So when we have the powers, then you have to multiply these powers. So this is important. This term raised to the power of m, that is raised to another power m, then you have to find the product of the powers. For example, square is to 3. Here the base is 4, whose power is 2, its power is 3. So this is 4 raised to 2 into 3, that is 6. So this is important laws or axioms, you can say, in indices. Then next is a negative power. So how to write negative power? Just now we had seen a last example where power is negative 3 to the power of minus 1. How to write that? So simple one is a to the power of minus n is the reciprocal of the term whose index is positive. Here it is a to the power of minus n is equal to 1 to the power of a raised to n. Just now we have seen example, this is 1 by 3. This is 1 by 3. So this is negative power, and next one is 0 power. 0 power. When exponent is 0, I am not talking of the base. Base is positive, not equal to 1 also. Okay, greater than 0 means it is not 0 here. So a to the power of 0 is 1 always. Means any base whose power is 0 is 1 always. Example, if I write 3 to the power of 0 is 1, 100 to the power of 0 is also 1. If I increase the number, whatever the number to the power of 0 is 1 always. I hope you are getting the points, students. Please note down these important results: 0 power, then multiplication with similar indices. Multiplication with similar indices. With similar means bases are different, indices are same. So that is a to the power of n into b to the power of n. So here I have taken two expressions. One term base a, exponent is n, index is n. Another term whose base is b, same index. Then you have to write ab raised to n. ab raised to n. So students, example for this is 2 into 5 is to 3 is nothing but 2 to the power of 3, 5 to the power of 3. So you can write like this also: a b raised to n is a raised to n into b raised to n. So this is one more law, that is multiplication with a similar number. And note that when the index is 1, base is a, then answer is a. If I write 10 to the power of 1 is 10, 10 to the power of 1, e to the power of 1 is e, this is 3, this is same number. So these are important laws of indices. Students, we are discussing the laws of indices, multiplication with similar indices. Then we consider division with similar indices. Division with similar indices means bases are different. A to the power of n divided by b to the power of n. A to the power of m, different number, numerator is a to the power of n, b to the power of n, bases are different, a, b, but indices are same. Indices are same. You can write a to the power of b raised to n. So this is 3 square by 4 square is 3 by 4 raised to 2. Raised to 2. Okay friends, we are discussing indices, the laws of indices. So here till now whatever we have seen, n is a positive number, negative integer. If it is a fraction, so fractional index, what happens? N is a fraction. Fractional index means it is in the form of p by q, where q is not 0. That term is called a fraction. Fractional index. So that is, we call this type of fraction index as a surds, radical, okay, radicals or surds. So that is a to the power of 1 by m, a to the power of 1 by m. So this is 4, if I write cube root of 4, this is 4 to the power of 1 by 3. If I write a number a to the power of n by m, how to write this? Base is a, power is n by m. So index is a fraction. So now this can be written as mth root of a raised to n. Mth root of a raised to n. Example, 4 square. This can be written as 4 to the power of 2 by 3. 4 to the power of 2 by 3, that is cube root of 4 square. So this is a law where we are using fractional index. So we will continue when the bases are. Next point is equality of two numbers. Equality of two numbers. Equality of two numbers. That is 2 raised to n is equal to 2 raised to 3. This is the condition when the bases of two equal numbers are equal. Bases of two equal numbers, this is equality sign. Bases of two equal numbers having same base, then their indices must be same. Remember that bases are not 0. Bases are not 0. They are not 0 and other than plus or minus 1. So bases should not be 0, they should not be plus 1 and minus 1. Okay. So then this implies, next, this is the first one. Second one, if I write a cube is equal to 6 cube. Equality of two numbers where indices are same but bases are different. So this implies a equal to 6. So here power is odd. So we'll get directly one base. If power is even number, so I will make more clear here. In this example, power or exponent is odd. Then we will have only one base. Here power is even, exponent is even. So the possibilities for base will be either a is minus 3 or is plus 3. So here two possibilities based on the powers. Equality of two numbers whose powers are same, then you can equate the bases. If the powers are odd, we will get one base. If the powers are even, then we will get either plus or minus. So these are important results. So these are the axioms, laws of indices. So these are important laws that if you want to become perfect, then you can apply these to find the values of x. For example, solve for x if it is given. If 5 root 7, 5 x minus 4, 35 raised to 3, a value will be 2, 5 by 4, 7 by 2, options given here 3. So student, let me solve this by using the laws of indices which we have studied just now. So 5 root 7 can be written as 7 raised to half, 5 into 7 raised to half raised to 5x minus 4. This is equal to 35 can be factorized into 7 into 5 or 5 into 7 raised to 3. 25 can be factorized at 5 square, 5 into 5, 5 into 5, 5 square, 3 by 2. So, okay. So, here I have used again the laws of indices. Now, the power of power, this is 5 to the power of 5x minus 4, one term, 7, 5x minus 4 by 2. So, what I have done? Power of power I have multiplied 1 by 2 into 5x minus 4. So, this is 5 cube, 7 cube. So, again power of power. So, 2 into 3 by 2 means 3. So, answer is 5 raised to 3. So, let me simplify this. This is equal to 5 to the power of bases are same, add the indices, 3 plus 3 6, 7 cube. So, now equality of number where bases are same, a to the power of n is equal to b to the power of n implies a is equal to b. So, 5 to the power of 5x minus 4, this is equality with 5 raised to x. Bases are same, so 5x minus 4 equate the indices. Then take this term minus 4 to this side, that becomes 6 plus 4 10. So, the value of x will be 2. Value of x will be 2. Okay. Even if we equate this, 7 to the power of 5x minus 4 by 2 is equal to 7 raised to 3. So, then we will get the same number. This is 3, 5x minus 4 is equal to 6, 5x equal to 10. So, x equal to 2. So, answer is A. Answer is A. So, here I have taken this example purposely so that I have applied many laws. First one you have seen here, AB raised to n, power of power, here also AB raised to n. Then equality of two terms whose bases are same, 5 raised to 5x minus 4 in the LHS, and here this I have combined with this, then I got the result as x equal to 2. If I equate this with this, then I got x equal to 2 is the answer. So, students, please like, subscribe this. Myself, Dr. Hanif Page. I am taking online classes for PGCET MCA Maths. So please like, subscribe. Okay. Thank you, thank you, thank you.